All right, BCA 101, we're in Unit 5, and this is Monday, 3/16/15. It's right after spring break. We did a number of items in terms of looking at technology and how we communicate, the PCs going out all the way to the internet. In communications, there are lots and lots of protocols. It's the rules for transmission, the rules that govern how information moves from one device to another. And so we looked at a couple groups here in this class. We're going to talk a little bit about Ethernet and Wi-Fi and how information gets from a PC or a laptop that's connected to a network, or maybe from your smartphone. And from your smartphone through the air to some device, an access point, which might be then connected into a network. Okay, so we have that protocol, and then we have TCP/IP, Internet Protocol, and we have those internet addresses we talked about, and we have a couple different methods of sending information there, and this moves us from one network to another. That actually happens through routing devices. Another key term to be aware of is bandwidth. It's what I call how big the pipe is, how many bits we can send through there. It's measured bits per second usually, and you'll hear things like 100 million bits per second. That's literally what it means. It can send 100 million ones and zeros every second. The connections in our classroom to the switch are 100 million bits per second. The media we already talked about. You can send it across wire, you can send it wireless, and we talked about fiber. Okay? And that's what we're talking about here in terms of media. Alright, so I'm going to move. Now we have the bigger picture here. And we talked about how the information moves from a PC into a switch. Okay, the switch connection to this other multi-layered switch, and then from there to a router, a routing device. Does network address translation, moves the information to another router on campus. This router on campus is connected out, actually two connections out to the internet. We have a firewall that protects the main part of the campus, and this device here, this router here, also acts as a firewall for this part of campus over here. In terminology, we talked about we have different devices. So we talk about all the end devices. We have servers, PC, laptops, all kinds of mobile devices, smartphones, tablets, etc. We have printers, and all these things communicate to the network. So we call them end devices. And we have intermediate devices, which are the switches, different types of switches, routers, and so forth. There's a router there that make our connections. So if you're thinking about it at home, an intermediate device at home would be a modem, and then you have that routing device at home that does a lot of things. It does this network address translation, which we talked about earlier. It does Wi-Fi. It also acts as a switch. Okay? In here we have private addresses, the same thing. Over here we have private addresses, and then network address translation converts them to what we call a public address that can be used out on the internet. So we call that a public IP. Internally we call them private internal addresses. All right, now talk a little bit more about inside the computer. Inside all devices is a physical address, sometimes referred to as media access control, MAC. address. But it's a physical address. It's assigned to the device. So like this PC, I'm over here on the left, it has this 48-bit number. First half of it, the vendor is a vendor number, and the second half, the vendor assigns that number. By doing that, all devices, whether they're this, whether they're phones, printers, anything connected to a network, has a unique physical address. Then, depending on where the device is, it gets a logical address. For example, your smartphone. If you have your smartphone here on campus and you hook to the Wi-Fi, which eventually hooks into the campus network, you'll get an IP here from NIACC to use. If you're at the Cabin Coffee and you connect your laptop, let's say, so you connect your laptop to their network, they're going to give you an IP address. But your devices always keep their MAC address, their media access control. That physical address stays the same. The logical address depends on what network you're connecting in on. Now those logical addresses can be of two types. They can be a private address that cannot be used out on the internet, or they can be a public address which can be used out on the internet. So what we do, like at your house, all your devices get a private address at your house, and then when the device sends something to the internet, it does a network address translation and it converts it, I got it written right there, converts it to a public address that can be used on the internet. And when it comes back, it converts it back. And we looked at some demo of how that works. Alright, and then to finish up, we talked about the question from the midterm on Airbnb, and we all talked about Uber, and we made reference to the fact they're a peer-to-peer. We talked a little bit about taxation, whether it's tax, regulation. A lot of times instead of cash, there's no cash because you're using your account numbers. Everything's you create a digital reputation. You know, if you stay at a lot of Airbnbs, eventually they say, yeah, they are a good customer to stay. Vice versa, you say, yeah, this Airbnb was a great place to stay. We talked a little bit about how to get the money. You can use a service like Square, or there's other services in which you can move money from one person's account to another using their services. They get a %. We talked about all this works because there's websites and apps, and then there's an infrastructure there that we're going to talk about during this particular part when we talk about networks and the internet. And that's it.